Hello, friends. Welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today, we are going to discuss about right circular cylinder. This is our part 2. So, we shall take some important questions and we are going to understand and solve them. So, our first question is this is our first question, which says if the surface area of a right circular cylindrical pillar is 264 meter square and volume is 924 meter cube, find out its diameter and height. So let us write total surface area. We should not consider total surface area in this case because we are talking about a cylindrical pillar. So for a pillar, we only consider the curved surface area. Because the base is attached to the ground and the top is attached to the ceiling. So only curved surface area should be considered. So the curved surface area is 2 pi r into h, where r is the radius and h is the height, is equal to 264, and the volume, it is pi r square h, it is 924. Now we are going to solve r and h. If we divide equation 2 by equation 1, by dividing equation 2 by equation 1, we get pi r square h by 2 pi r h equal to 924 by 264. So here pi and pi can be cancelled. H and h can be cancelled. R and r square can be cancelled. So we are left with r by 2. So this 2 can be transferred to the right side. So r is equal to 924 into 2 by 264. So 132 into 7 is equal to 924. So the value of r is 7. R equal to 7 meter. Therefore, the diameter should be 14 meter. Now, now we need to find out h. So from equation 1 we can write h is equal to 264 by 2 into 22 by 7 into r, that is 7. So 7 can be cancelled. 2 1 3 2 and 22. If we cancel it by 2 we get 11, and if we cancel 132 we get 66. So it is equal to 6. That means h is equal to 6 meter. So this is our answer. Now friends, let us proceed to our next question. This is our question number 2, which says a right circular cylindrical tank of 9 meter height is filled with water. Water comes out from there through a pipe of radius 3 centimeter with a speed of 225 meter per minute, and the tank becomes empty after 36 minutes. Find out the diameter of the tank. So this is our diagram where we can see a big tank, cylindrical tank, whose height is given 9 meter, and we can see a pipe through which the water is passing out, through which the water is we can see there is another pipe, another small pipe through which the water is being transferred. The radius small r of this pipe is equal to 3 centimeter. This is our radius, and we have assumed the length of water column in it in 1 minute is equal to 225. So for our understanding, we can assume that the length of the pipe, which is not given, the length of this smaller pipe is not given. So in this case we are assuming the length of the water column formed in 1 minute is equal to the length of this pipe. Okay, that means 225 meter. So the radius and the length is here. So when the total water is completely transferred, then the volume of water that has been transferred should be equal to the volume of water inside the tank. Therefore we can write the volume of water inside this tank, which is equal to pi capital R square into H, that means 9. Okay. The units are in meter, which is equal to the volume of water which has been transferred to this pipe, which is equal to pi into small r square. That means, but we have to keep the units same, so we need to transfer it into meter. So we need to divide it by 100. Pi r square into h, which is 225 meter. This volume of water has been transferred in 1 minute. So in 36 minutes, the volume of water transferred should be equal to this into 36. Okay, so see it carefully. This is the volume of water that has been transferred in 1 minute. Pi small r square into h. But the pipe needs 36 minutes to drain the water completely. So we should multiply it by 36 to get the total volume of water. And this volume should be equal to this volume. Now we need to find out capital R first. Pi and pi can be cancelled. 9 and 36 can be cancelled, and we can write 4. So r square is equal to 3 by 100 square into 15 square into 2 square. So r should be equal to 3 by 10, 3 by 100. We are doing square root on both sides of this equation. So 3 by 100 into 15 into 2. We cancel it by 5, we get 3, and if we cancel it by 5, we get 20. Now we can cancel it by 2 and get 10. So 9 by 10. This is our radius. That means it is 0.9 meter. Therefore, the diameter should be equal to 1.8 meter. So this is the solution. So this is our question, which says the inner and outer diameter of a right circular cylindrical pipe open at two ends are 30 centimeter and 26 centimeter respectively, and length is 14.7 meter. Find the cost of painting all surfaces at rupees 2.25 per decimeter square. So the pipe looks like this. The outer radius is equal to 15 centimeter. and the inner radius small r, which is equal to 13 centimeter, and the length of the pipe is 14.7 meter. That means 14.7 meter. Okay, now we can convert all these units into decimeter for our to make the calculation easier. So 15 centimeter is equal to 1.5 dcm, 13 centimeter is equal to 1.3 dcm, and 14.7 meter is equal to 147 dcm. Therefore, total surface area which is equal to, we know, inner curved surface area, that means 2 pi smaller h, outer curved surface area, that is 2 pi capital R h, plus this region. Okay, this region is twice, so 2 into pi into capital R square minus small r square. So this is our total surface area. Now if we plot the values, let us first take 2 pi common. So we are left with r into h. So our r is, small r is 1.3 into h, which is 147. And now capital R into h, that means 1.5 into 147 plus a square minus b square, that means a plus b into a minus b. So r plus small r. So r plus small r is 2.8 into r minus r, that means 0.2 dcm square. So if we calculate this value, we are getting 2590.72 dcm square. Now for 1 dcm square, the price is 2.25. Therefore total cost of painting, should be equal to 2.25 into 2590.72. So this is what we are getting. We can say approximately it is equal to 5829 rupees. Okay. So I hope you have understood it. Thank you for staying with me. Bye.